Good afternoon, everyone. Welcome to the webinar on data science. I'm looking at the list of participants. It's exciting to see a lot of guests this afternoon. We have guests from Singapore, from not just from the Philippines, from Malaysia as well. And we have a lot of people across Asia and from Cebu in general. So welcome to the webinar on data science. This is a career development program of Cebu IT BPM organization in partnership with Go Philippines and Microsoft. Um, this is a career building program to make Filipinos highly employable and be able to build a career in the IT BPM industry. We have a varied list of training programs to help you build a career. One of which is data science, which is the topic of today's event. Okay, so I'd like to give a lot of time to our speaker, and of course, we are also graced this afternoon by the president of CIB.O, Mr. Pert Cabatanya, um, who is with us to listen also to our guest speakers. As you know, data science is an essential part of many industries today, and given the massive amounts of data that are produced, and it's one of the most debated topics in IT circles, it is popularly known or has grown over the years, and companies have started implementing data science techniques to grow their business and increase customer satisfaction. In this program this afternoon, a lot of doors will be open to you, to all our participants in the world of data science, and will be shared to you by our um guest speakers. So, without further ado, I'd like to give a brief introduction to our first speaker. He is the executive director and founding board member of the Analytics Association of the Philippines, which is the Philippine National Industry Board for Analytics and Artificial Intelligence. As executive director, he implements the various nationwide programs of the AAP, which include, among others, education, labor market intelligence, and policy, legislation, and standards, with the goal of building the analytics and AI ecosystem of the Philippines. He is also the Chief Analytics Officer of eClaro, a global business and technology consulting company delivering top talent to clients across diverse industries. And in this role, he is responsible for refining strategies to initiate and expand key digital transformation services, especially the fields of analytics. He has been involved in several roles at Accenture, IBM, and Teradata. He is also a faculty of the University of Asia and the Pacific's Master in Applied Business Analytics program. Ladies and gentlemen, let's put our hands together to the one and only Mr. Sherwin Pilayo.
Maraming salamat, buddy. Good afternoon to everyone. Isang magandang hapon sa ating lahat. First important question. I'm not used to Teams anymore. Is my background showing the way it is supposed to be shown? Or is it inverted? Are you seeing it as inverted or
Inverted, pare.
okay? Hold on. So there, looks okay.
There you go.
All right, okay.
Got it.
Because in my view right now I'm inverted. So in your view it's now okay. So
Yeah.
thank you very much first of all to I think it was Go Philippines who actually invited me here, and thank you very much to the Cebu IT BPM organization, Sir Buddy. Thank you very much for having me here. It's an honor to be here. The AAP, the Analytics Association of the Philippines, while primarily established in the NCR, and as you mentioned, it's the National Industry Board for Analytics and AI. We're actually actively looking for partners across various regions, and we're hoping that the Cebu ITBP organization will be our partner in propagating analytics and AI, within the Visayas region. So after this, Sir Buddy, let's talk. Okay. Let me share my presentation now. Okay. Um, can someone confirm, please, that you can see my presentation?
Yes, Sir Sherwin, we can
Yes.
see the presentation.
Okay, maraming salamat. So, the topic for today, and I know I probably have an hour to do so. There are a lot of topics that I think I was asked to present. So let's see if I can put this in an hour or less. So the topic that was the topic for today is actually about demystifying data science, career transition into data science. But no, to truth be told, when I was introduced and the organization, you actually never heard anything about data science, right? And I think it's one of the things that I'd like. If there's one thing that I'd like for everyone to take out of this webinar is forget data science for now. Think of this as a bigger picture. Think of analytics itself, and later on you will see that when we look at careers in data, it's not really just data science. There's a bigger world out there in data, and that's analytics. And data science is actually just half of it. No, half of analytics is data science. So let's talk about careers in analytics and demystifying what analytics is really all about. Whenever I do this webinars, sorry, before I start, especially I'd like to ask a question first. Can I see a raise of hands first? Um, Anyone who's familiar with Project Sparta, can you please raise your hand? I just want to get a feel of participants in the audience. Okay. Raise your hands if you know about Project Sparta. Because if you know about Project Sparta, I'll be calling you on this. Let's make this a recitation. This is SP 101, getting grounded on analytics. Okay, so you're going to be very familiar with this already. First, there are a few additions to this. Whenever I do a talk about analytics, I always start with this story of Aling Lala and her sari-sari store. So Aling Lala is the savvy businesswoman. She has had her sari-sari store for decades already, and she has actually used her sari-sari store to provide livelihood for her family. Okay, so let me run you through a normal day, normal week, a normal month for Aling Lala as she manages her sari-sari store. So on a daily basis, every time that someone buys at her sari-sari store, she logs it in her notebook. Okay, she logs who bought what item, how many items, the total cost of the items, whether or not the customer actually paid or took out a loan and promised to pay another day for the items that he or she has bought from Aling Lala Sari Sari store. So she just keeps a notebook on that, and she logs every transaction. At the end of the day, she has this another book where she calculates and tabulates all of her days sale. Of course, I mean she has a sari sari store. She wants to know how much she earned for that day, but she also wanted to find out if there are items in her store that she needs to buy more inventory of, if there are items that are actually going to waste because it is not being bought at all. Okay, so those are the kind of the details that Aling Lala puts in her logbook at the end of the day. Now, at the end of the day, she notices that the the revenue actually, or the profit that she actually gained for that day, is a bit lower from the previous 2 days. In fact, when she browsed through her that logbook that she has, she noticed that for the past 3 days, her profit was actually declining. So she wanted to know why. She was curious why it has happened. And since she kept a daily record of all of the transactions and the things that's happening in her store, months, years worth of data, she was able to find some trends and patterns on the details that she has in her logbook. She found out that it's not always that her revenue or profit is declining, no, on a regular basis. What she found out though was that there are certain items that sell less during certain months of the year, but at the same time of that year, certain items would actually sell more. So for example, items that are used to cook spaghetti, for example. So pasta, sari-sari store yan, pero may pasta, meat sauce, mga hot dogs. Okay, she found out that those items sell actually more during the months of April and December. So she asked her customers, so why are you buying spaghetti stuff during April or December? They told her, it's because April, usually during the time of graduation, we want to celebrate the graduation of our children. December, of course, it's Christmas. The holiday season, it's part of our handa during Christmas to cook spaghetti. Okay, so based on her customers' feedback, those are the items that actually sell more during those months. But certain months of the year, yung items for spaghetti actually sell less. And in fact, some of her items actually go to waste because those items do not sell up outside of the months of April and December. Similarly, there are items that actually sell a lot more during summer, like halo-halo, ice cream, because it's hot. And then hot noodles, instant noodles, instant mami, for example, they sell less during rainy season. Sorry, they sell more during rainy season because people want something hot in their bellies to eat. So, just basing on the trends and patterns from the details that she got from her logbook, Aling Lara now found that there are certain items that sell more during certain parts of the year. There are certain items that sell less during certain other parts of the year. So it wasn't enough for her to know that. Of course, she wants to maintain a certain level of profit. So what she did was she actually changed her shopping schedule, change her restocking of her inventory. She made sure that items for spaghetti are more abundant, or much more during the months of April and December, less during other months. She makes sure just that she has stock for ice cream ingredients for halo halo during the summer, less during the rainy season. So that was an action that she took based on the trends and patterns that she saw from the details of her logbook. It did stop there because now that she has a new way of stocking her inventory, she wanted to find out if it did actually if it actually did make a change in her profit. Okay, so fortunately, she was able to see a steady increase in profit because she is now selling the right items at the right time. She still continues to log details about every transaction. She still continues to tabulate and see if there are any other trends and patterns that she might see so that her revenue or profit is steadily increasing. So that's the story of Aling Lala and her sari-sari store. Let's look at the story of Mang Isko and his yellow corn farm. Mang Isko not at all related to the presidential candidate that we have. In any case, so Mang Isko has his farm for several decades now, inherited from his father, from his grandfather, from his great great grandfather. So he has several hectares of yellow corn farm. Like Aling Lala, every time that Mang Isko goes out to his farm, he makes sure that he logs every activity in a notebook. The time that he planted the yellow corn seeds, the time that he watered, the amount of water, the type of fertilizer, even the distance between seedlings when he planted those seeds. So for him, based on experience, those are the information or the details that he need to keep track of to see if he's going to make an increase in his harvest at the end of the harvest season. So at the end of the harvest season, of course, Mag Isko would like to know how much yield did his yellow corn farm make and how much revenue he made. Now, for this particular harvest season, he noticed that it was actually lower than the previous harvest seasons. So he was curious. So he wanted to understand why his yield and therefore his profit for this harvest season was actually lower than previous seasons. So since he keeps track of all of the details of all of the things that he did during planting time, he noticed, that there are certain combination of seed types, fertilizer, amount of water when he planted the corn, and even the distance between seedlings that affect the amount of harvest he gets every harvest season. Okay, so in this particular season, he noticed that that particular combination did not actually work well. That's why there was a decrease in yield. Okay, so it didn't stop him from that. No, now that he knew what happened, he now looked into the other seasons where the yield was actually higher and greater, and then he made sure that now he used those details. The type of fertilizer, the type of seed, the amount of water when he actually planted, and he just made sure that he used the proper combination so that it will ensure a steady increase, or that his yield and his profit will not actually decrease anymore. So that was the action that Mang Isko actually took to ensure that his yield for his yellow corn farm is not decreasing over time. He still logs every activity because he wants to experiment new seeds, new types of fertilizer, planting at different times of the year. But he still meticulously keeps track of all of the details to see if there's a better combination of these factors that will allow him to increase his harvest further. Okay, so these are the stories of Aling, Lala, and Mang Isko, and these are actually true stories. Mang Isko is actually one of the yellow corn farmers in Isabela that we had the project on when I was with IBM, exactly doing these things, finding the right combination of seed type, fertilizer, even the type of soil, the amount of water that will ensure that the yellow corn farmers in Isabela will increase their yield. Aling Lala is one of a member of a big cooperative group, which we help in ensuring that they understand the marketability or the saleability of the products that they sell. Now, that cycle that you see in the middle, that's what you actually call the data life cycle and the value chain. Should I now call on those who have taken SP 101 from Project Sparta? Okay, this is a review for all of you here. Okay, so the data lifecycle will always start with data. This is the creation and generation of data from its source. This is the birth of data. This is the transaction that customers make in adding Lala store. These are the things that Mang Isko does when he goes out to his farm. That's the birth of data. Data gets transformed. The first transformation that data goes through in the data lifecycle is it is transformed into information. This is the time that all of that data is collected from the various sources into a single repository to answer what happened. So as you may noted, Alilala at the end of the day would tabulate everything that has happened at her store, to see how much she sold for that day, what items are actually she needs to restock, and which items are probably expiring because she wasn't able to sell that. Okay, so that's the first transformation. That's the first question that we answer in the transformation of data. What happened? It's like a status report, something that happened in the past. Okay. Um, as you saw, Mang Ispo and Alilala was not satisfied. They were just curious on, so why did it happen? The next transformation then is information goes through this transformation into insights. This is where we find patterns and trends in the information that we collected, so that we can answer the question, why did it happen, and what could likely happen next. Okay, so if you don't do anything, okay, what's going to happen in the future? If the trends and patterns
Sir Sherwin, you're on mute. We can't hear you, sir.
was I on mute
Uh,
for
no,
the
it
longest time?
it was only for like 1 minute, two
Okay,
seconds
all right,
even. Yeah.
okay.
Thanks.
So I might have pushed something here. Okay,
Mute mo sad. Mute mo sad siya.
Sherwin, you're muted,
Sabi siya,
Sherwin.
Ana, sir, na-mute ka. Siya, okay na. Siya,
I
okay
think
ka na.
someone
Kasi
is someone muting
mute siya
actually.
1 minute. Ano siya, okay. Na-miss na ako. Kadiyot. Yeah. We're going back. I-mute na sa niya yung sir ulit.
Someone might just be muting me. So okay, let's see. I'm monitoring the volume. Let me see there. Okay, let's see. Can you hear me now?
Yeah,
Okay.
you're live.
All right.
Sure.
See, I'm not going to touch anything. Okay. Insights, finding patterns, trends in data, answering the question why it happened, what could likely happen next. And then, as you saw, Aling Lala and Mang Isko was not satisfied with that. They wanted to ensure that they continue to increase their profits, so they had to take action. That's the last. Well, that's the last actually. That's the next transformation. When you go from insights to imperatives or to actionable insights. Now you take action. This is where we develop various options to suggest what should be done next. If you want to reverse a something that is negatively happening, like a decrease in sale, then you need to do something. Okay, and so that's the next transformation, transforming insights into actions or imperatives. But as you see, it's a cycle. Okay, since now you've taken action, there are new data that can be generated from the actions that you have taken. So it continues now. Data is new data is created. You need to consolidate that, gather that information, continue to find trends and patterns, and do actions. So this is a cycle of continuous improvement for everyone. This transformation of data to information to insights to imperatives is actually analytics. So this is how we define analytics. Analytics progresses data along its value chain. So data, information, insights to imperatives with the purpose of delivering the right decision support. Okay, let's pause for that. Okay. Analytics can only provide decision support. It will not make the decision for us. It's only going to give us options on what we should do next. But essentially, it's really still up to us whether or not to follow the suggestions that analytics will provide. So we're still maintaining that analytics is a decision support system. It's not going to make the final decision for us. Okay. So, di ba, I mean, there's that danger in AI that AI is going to replace us. It's the same case here. No, ultimately, it's still going to be us who's going to make the final decision. Analytics, AI is just really going to support us. Who do we deliver this decision support? To the right people and digital processes. Okay, so of course it's going to be us who's going to be needing that analysis of the information. Nowadays, with the advancement in technology, we do have digital processes, smart cars, okay, self-driving cars, smart appliances, refrigerators that would know whether you're low on milk or you don't have eggs anymore in your refrigerator. That's analytics telling those smart appliances, giving them decision support to inform you that, hey, something is happening. So that the definition, previously the definition of analytics is just providing support to the right people. Now we've included into the definition providing support to digital processes as well. It is important that the decision support is given at the right time because you need to have that information when you need it. Okay. Lastly, and this is important, we need to use data for the greater good. Okay. And I'll have a dedicated slide for that. Forget everything that I'm going to say. For as long as you remember to use data for the greater good, then my job is done here. This is how we define analytics. Okay. Now, going through this cycle again, these are the things that what you might heard. Okay, these are some terminologies that you might have heard already. In data, you might have heard the terms data governance, data management, data security, and privacy data ethics. Okay, so this is how you use the data. Which data do you actually use, and how you ensure confidentiality and security of your data. In information, these are the terms that you might have heard already. Data engineering, data warehousing. Data warehousing is that big database where you consolidate all of your data into a single repository. Business intelligence, that's another term that is common in that stage of information. And since we want to answer the question, what happened, we want to describe what happened. This is where we do descriptive analytics in the information stage. In insights, this is where you hear the terms data science, machine learning. And since we want to answer the question, why did it happen? We want to diagnose the reason why things happen. This is where we do diagnostic analytics. Since we want to answer the question, what could likely happen next? We want to predict what's going to happen in the future. This is where we do predictive analytics. And lastly, in imperatives, this is where you hear terms such as recommendation engines. You may know it or not, you've encountered recommendation engines already. Whenever you search something in Google and suddenly you find that same ad in Facebook, that's social media's recommendation engines working for you. If you go online shopping in Lazada and Shopee and suddenly you find things that you browsed through somewhere else, and now these products are appearing in your online shopping, that's recommendation engines working for those applications, right? You heard terms such as optimization, simulation, and this is where we develop suggestions on what we could do next. We want to be prescribed on actions that we want that we can do next. This is where we do prescriptive analytics. So, these are terms. This should not really be new to you anymore. They might just be called other names. They might have technical terms, but you've encountered this on a daily basis. Now, what's important here, we're talking about analytics. My second slide is really saying, data science is just half of analytics, and this is that half actually. On the right side, when you're dealing with data and information, another term that you might heard is big data and analytics. On the left side, that's data science and analytics. We're I'm sure you're familiar with the acronym DSA already. That's data science and analytics. But as I mentioned, that's only the left side of it. Big data and analytics is more on the data engineering part of that. And why is this important? It's because you can actually build careers not only in data science but also in big data and analytics. In fact, there's actually higher demand in data engineering than data science. And I'm not saying that because I'm a data engineer. I started as a data engineer. Okay, so these are the analytics job families. It also corresponds to um, specific stages of the data value chain. In data, corresponding to that would be a data steward. In information is a data engineer. In insights, that's where data scientists come in. When you develop the actions for your organizations, that is being done by the functional analyst. And lastly, the one that actually, of course, puts together all of these, make sure that everyone is actually working together for the successful delivery of an end-to-end analytics project is your analytics manager. Okay, let's look at each of these analytics job families. There's kind of a correspondence on certain jobs that we know already. Look at data steward as a librarian. Okay, baka kayo mga kabataan, di na kayo nakapasok sa libraries natin nyo. You've forgotten how your library look like. But you have your friendly librarian there. Okay. The data steward, like, librarians, you would really have to go through them before you can get data, before you can actually even borrow a book. Okay. Your data stewards would have to ask you, oh, why do you need this data? They are the gatekeepers of data. They are the custodians of data. They enforce data security, privacy. They need to ensure that you're going to use data ethically, okay, and in the right manner. They also know if there's something that's wrong with your data, they know how to fix it. Okay, that's the job of the data steward, and which is closely related to what librarians actually do. So there's that stereotype of a librarian that's very strict, when you're borrowing books. I mean, because librarians and data stewards would have to be very strict also in giving out, the books and giving out data. Okay, collecting all of those data, putting them into a single repository, that's the job of a data engineer. And this is closely related to custodians. Okay. As data engineers, we jokingly call ourselves as data janitors. And we're proud of that because we like dirty data and we like to clean data. We're the Marie Kondo of analytics. Okay, we want to organize things. So we are the ones who collect all of the data, put them into single repository. We ask data stewards, okay, there's data missing, there's errors in this data. They tell us how to fix it, and then we program. We do the codes and fix the errors. That's our job as data engineers. We provide data, high quality data, good data, so that our data scientists can do our job. And data scientists are like detectives and investigators because they are the ones who's going to find those hidden trends and patterns in data as data transforms to information into insights. Okay, where data scientists will really use the math and statistics knowledge that he or she has to identify those trends and patterns on data. Functional analysts or data analysts are business minded people. Actually, they are the ones who will be able to translate the insights data scientists gather into something that the leadership of the organization can understand. Okay, so it's the job of the functional analyst to look into the suggestions that analytics came up with and see what's going to be applicable to the organization or to the business. Lastly, your analytics manager are like coaches, or they're actually even like cheerleaders. Okay, they need to make sure that every member of the project does his or her role to ensure that the project is delivered on time, on budget, okay, and at cost. Okay, so that's the summary. If you look at how each of these roles are closely related to jobs that you may already know, that's how you can actually interpret the various job families. To put in some more context, okay, so these are the actual roles, the field of expertise, and the typical job titles that you would hear. Okay, so data steward, again, they are the ones who enforce data privacy, data security, ethical use of high quality data. It is not a technical role. Their field of expertise is more on business and industry. Most of the times, they have some legal background as well because they need to know policies such as the Data Privacy Act. Okay. Again, this is not a technical role. Okay. So titles would be data privacy officer, your data security officer, data curator, data librarian. Okay. Data engineer is the most technical of all of the analytics job families. Okay. Because the field of expertise of data engineers is really in IT, information science, computer science. We are the ones who construct these pipelines. Okay. Of pipes, from the sources of the data sources to the centralized data repository or to the data warehouse. We create the programs that extract, clean, transform, and load data into this single data repository. Typical titles would be ETL, extract, transform, load, developer. This is where you have your data architects, data warehousing professional, and big data engineer. Okay. Next would be the data scientist. Okay, I know the initial thought is that this is all data science, but actually data scientist is one of the job roles in an end-to-end analytics project. Okay, data scientists would leverage the statistical techniques so that they can find those hidden trends and patterns in data so that they can derive new insights from both quantitative and qualitative data. The field of expertise needed to become data scientist is really in math and stat. So, sorry, wala kayong kawala doon. If you want to really be good data scientist, then you need to have very strong foundation in math and stat. I'm good in math. I never really understood stat. That's why I became a data engineer. Okay. Typical job titles would be statistician, advanced analytics professional. Okay. I saw myself muted again. Okay. So functional analyst, this is not a technical role. The field of expertise again is on the business and industry because functional analysts are the ones who's going to translate the insights from data scientists into something that the business or the organization will have to understand. So communication skills is actually very important for functional analysts, and typical titles would be mostly operations, research analyst, HR, marketing, financial analyst, operations analyst. Okay, most of your school administrators would fall under this category, functional analyst. Lastly, of course, you have your analytics manager. They are your typical project managers. Analytics projects are, typical projects as well that needs to be managed by a person. In this case, your analytics manager. What's important though is that the analytics manager would know the responsibilities of each of these individuals so that he or she would know whether the project is slipping as far as schedule and cost is concerned. So typical titles would be your chief data officer, project manager, data engineering, analytics translator. Okay. What's important to note here is that when you have these analytics job families, these are distinct career paths that you may actually take and develop as you build careers in data. You can actually move from one job family to another. That's okay. But if you want to progress, if you want to, progress your careers, you can actually progress in a specific role. Okay, so like for me, I transitioned from being a data manager to a data engineer to an analytics manager. But I do have senior people who have been data engineers, for the longest time, and they are now actually data architects. So they are architecting really large, data projects. So you could actually build careers as data engineers, data scientists, functional analysts, and even analytics managers. There are a few overlaps, but when we define these job families, these are distinct enough so that you can build your careers on for each of these job families. Okay, skills. Okay, in 2017 we participated in this project data analytics raising employment from the Asia Pacific Economic Conference that was in 2017 in Singapore, where 17 economies came together and identified these 10 analytics competencies. So we're talking about these are the skills that you need to develop as analytics or data professionals. This year, actually, we are working with the DICT to come up with the Philippine Skills Framework for Analytics and AI, which is going to have some basis in the same framework such as found in Skills Future Singapore. Okay, for now, this is the framework that we are using, but again, by the end of the year, we're going to be launching a different framework, still built on top of these competencies. So the first four competencies: domain knowledge application, data management and governance, operational analytics, data visualization, and presentation. These are business organization skills. You need to know the business, you need to know the industry, you need to know how to manage your data, data privacy, data security. You need to understand how your business or organization operates. You need to know how to visualize and present your data. You need to know how to tell a story out of your data. So those are the four business or organizational skills. The next five skills are the more technical skills. Research methods, which would tell you these are the way to properly conduct research, proper way to conduct surveys. Okay, that's how we do research and development. Data engineering will teach you on how you create your data warehouses, create those extract, transform, load programs, build those data pipelines. Statistical techniques talks about using really a lot of statistics, probability, combinatorics, and all of that to find those trends and patterns. Data analytics methods and algorithms will introduce you to all of the really good things that data scientists go through, where they find those trends and patterns. Computing is essentially programming. So programming in such as the structured query language, Python, R. Okay, so those are the five technical skills. And the last would be the 21st century skills. These are communication skills, critical thinking, self-relearning skills. What we typically call soft skills, but in truth, these are the hardest skills to develop because there's really no training that would teach you those 21st century skills. These are life skills. You'll have to train them for the entirety of your life to really hone your proficiency in the 21st century skills. So these are the 10 competencies. Part of the framework actually introduces 3 levels of competencies and 3 intermediate and expert. So for each of the 9, let's leave out the 21st century skills because there are no proficiency levels there. So the first 9 competencies, each of the competencies has an entry definition, intermediate, and expert. Entry, you can perform tasks with supervision. Intermediate, you actually design the work that is going to be done by the entry level people, and you can work independently. Expert will actually, this is where you create innovation, new approaches, new solution to the problem. Okay. Let me just give you a sample. I'm going to send you the slides, but this is a sample of, say, domain knowledge and application. And you'll see later, medyo madami yan. So I'm not going to go through that in the interest of time. But you'll see here, each of these competencies has an entry, intermediate, and expert level. So basically, these are the expectations for you if you are beginning in computing, or your intermediate level already, or in the expert level. For schools and higher education institutions, this framework is actually used to develop curricula. The way that this was designed is level 1, the entry levels are used as learning outcomes for bachelor's program. Level 2 are the learning outcomes for a master's program, and level 3 are the learning outcomes for a doctorate program. So this is how we actually working with the Commission on Higher Education to define degree programs, and I'll mention that later. The education programs that we're doing with the Department of Education and with CHED. Okay. This again are the list of the 21st century skills. So this is what we call the professional maturity model. The stars in the middle show kind of the maximum, the minimum expected proficiency level for that competency for a particular role. And as you can see, not everyone is required to be at expert level at all competencies. It's again dependent on the field of expertise that is expected from you. So data steward, for example, again, we mentioned that this is not a technical role. It's more of a business an industry role. That's why the first 4, nandun yung expert level expectations for data stewards. Very low expectations on the technical skills such as research methods and computing. Data engineering, obviously, of course, will have high expectations in data engineering competency. But you look at data scientists, they are expected to be at expert level at almost all of the technical skills, from research methods to computing. Functional analyst, again, the expectation is more the domain. That's why there's expert level in almost all of the 4 top skills, and then the next 5 technical, very few, very low expectation, entry level really on the technical skills. Now, if you look at the analytics manager, the analytics manager is expected to be at least at entry level for all of the technical skills. Why? Because you need to know what your data engineer and your data scientists are doing. They're the more technical roles. Okay, so you need to be able to understand that your data engineers and data scientists are actually doing the right thing. Okay, and that's your role as an analytics manager. So you need to know a bit of everything across all of these roles. Okay, so this is the professional maturity model. Schools use this to create curricula for data engineers, for data scientists. Organizations, companies use this as a career framework for their data stewards, data engineers, data scientists, so that they know when to promote a certain person. If, for example, you have data engineers and they want to move into their career path into becoming data architects, then they use this competency framework as a performance management mechanism. Okay. Okay. Learning analytics. So these are the initiatives of our government that the AAP is working on so that you could learn analytics. As I understand it, most of the student participants here are already in college, right? And some of you are already graduating. So medyo hindi niyo na maabutan with the Department of Education, where we're pushing to have analytics courses in STEM initially. So this is under discussion. What we want to do is we want to produce employable associate data analysts after graduating from grade 12. Okay, so that's why we're pursuing this with the Department of Education. In discussions with industry partners, companies, they said that they have identified certain skills that if taught in grades 11 and 12, they will be more than willing to hire them after they graduate in grade 12 as associate data analysts. So that's something that we're working with the Department of Education. Okay. The initial talks is with STEM, but we've also proposed analytics specialization in ABM and in TechVoc. DepEd actually wants a totally separate track for analytics. So it's at par with STEM, ABM, and even TechVoc. But that's discussions still ongoing. From CHED, okay, in 2013, I believe there were already courses approved by CHED on the Bachelors of Science in IT and Business Administration, specialization in Business Analytics. I'm very familiar with that because it originated with IBM partnership with CHED, and I think I thought the first batch of faculty to teach those courses. Okay, this year, CHED also launched the 2-year Associate in Computer Technology in Data Engineering. Okay, again, in consultation with our industry partners, we deemed that in order for us to produce associate data engineers who can actually do data engineering work, it's enough for them to complete a 2-year Associate in Computer Technology program in college. Okay, so a student who completes this 2-year Associate in Computer Technology in Data Engineering can be employed already as Associate Data Engineers. There's a CHED memorandum order there. I think we have a couple of universities here. I hope that you're familiar with that CMO on the Associate in Computer Technology, because you could actually start offering that program already in the coming school year. Under discussion with CHED is the Bachelor of Science in Data Science. Now, with data science, given the number of math and statistics subjects that need to be taken by future aspiring data scientists, unfortunately, we cannot compress it into 2 years. If you want to build a career in data science, and if you want to be educated in data science and become an associate data scientist, then you'll really have to take a 4-year bachelor's program in data science. There are some universities such as UST Mapua who's already offering a Bachelor's of Science in Data Science. For those that are still under CHED, you might have to wait until next year for the CHED Memorandum Order for the BSDS program to be released. Okay. In TESDA, we're working with TESDA to create TechVoc courses in analytics and AI that's coming in parallel with the work that we're doing with the ICT on the skills framework. It's important that we establish first the skills framework in analytics and AI before we create this TechVoc courses with TESDA. most of you is familiar already with Project Sparta. If you're not done yet with your courses, please finish them. It's the third year. We're still seeing if DOST is going to extend that, but hopefully those who have started will be able to complete and graduate this year. Lastly, and just launched yesterday, is another initiative by the Department of Information Communications and Technology called Tech Trends. These are free online webinars on emerging technology trends such as analytics, AI, cybersecurity, the gig economy, blockchain, cloud computing. Okay, so there's a badging system. There are webinars that will give you a basic badge, and then you can move on to an intermediate badge, and then you can move into an advanced badge. Okay, so for all of this information, you can visit the Facebook pages of all of these government agencies. Tech Trends, for example, was launched yesterday. So if you go to the Facebook page of DICT, you'll find the video launching Tech Trends. The first webinar is actually going to happen on May 13, and that's the basics of analytics. So yeah, these are opportunities where you can actually learn analytics. A lot of initiatives by our government agencies here. Okay, so building a career in data. So in which industry can you actually build a career in data? Any industry, all industry will actually need data professionals. What I'm showing you here is actually an excerpt from the 2022 Philippines Analytics Sector Labor Market Intelligence report. This shows the top industries and the bottom 10 industries where we measured their analytical maturity. Okay, from a level 1 to level 5, 5 being the highest in analytical maturity. Because what we're saying is that all industries would need to be analytically mature. They need to be data driven. So those organizations in these industries would have to be data driven. From the study, we found out that banking, financial services, BPM, telco, and IT, they're the top 5 industries where they are mostly data driven already. In the bottom though would be wholesale, mining, nonprofit, real estate, retail. They are in the bottom. But as you can see, there's really a wide range of industry where you can build a career in data. And what I will always say is that yes, be a data scientist, be a data engineer, but hopefully you can focus on a specific industry, and in an industry that where you can really help, especially depending on where you are, what region you are in. For example, when we're promoting this in Isabela, that is really an agricultural community. We're building data scientists there and data engineers. When we teach analytics, there's always case studies that is geared towards using data for agriculture, like the story of Mang Isko, for example. So that's the kind of thinking that we'd like to promote, because think of these industries as verticals, and then analytics would be the horizontal that cuts across, because analytics is going to be applicable to any type of industry. Okay, learning and career paths. So probably just a summary of how you can go about this. So from senior high school, again, you can, once we rolled out that program with the Department of Education, you can graduate and be employable already as an associate data analyst after graduating from senior high school. Then you can take, if you want to, you can actually take a bachelor's degree program in BSIT or BSBA with specialization in business analytics. So you can be a data analyst, employed as a data analyst after that degree. As I mentioned, you can get that analytics track in STEM in senior high school, and then proceed to a 2-year associate in computer technology, so that by the end of that 2-year program, you can be employed as associate data engineer. So that's another learning and career path for you. Or you can actually take that Bachelor's of Science in Data Science, where you can be educated, in all of the math and stat that you need for data science to become an employable associate data scientist. There are master's program currently, like for example in AIM, UP, UANP, offering master's program in data analyst, data engineering, and data science. So if you want to pursue further studies, then that's available for you. Then you can be employed as data analysts, data engineers, data scientists. If you want to grow a career in data stewardship, then you can start as a data analyst, get a degree or an education in data analyst, and become data steward through job experience. Okay. Data stewards and analytics manager are more senior roles. So you need to become one of the three roles before you can proceed to becoming data stewards and analytics managers. And then, once you progress your careers in any of these 5 roles, you can be a chief data officer, chief information officer, or, what I do in Eclara as chief analytics officer. So that's how you can learn and then build your careers in analytics. Okay, I think I'm down to my last 2 slides. Okay, now this is important. I never end my discussion on analytics without discussing using data for social good, because as we define analytics, it always has to be for the good of society. So whenever we talk about data for social good, we always talk about data ethics. And there are a number of things that you need to consider when you talk about data ethics, but I'd like to highlight 2 of this. One is intention. Okay. Whenever you start doing your analytics project, you will definitely have to gather data. You need to be very clear of why you need the data in the first place, what you will gain from gathering, consolidating, transforming, gathering insights from the collected data, and what changes do you intend to make after the analysis of that data. So before you even start, doing all of the nice data engineering or data science stuff, as you define your problem statement for your project, ask these questions first. What are you intending your project to do? Okay, intention is key. It's one of the first questions that you need to ask to ensure that you're going to use data for social good. Last is outcomes. Analytics is it's unpredictable. You don't really know what insights you're going to gather. And again, that's a job of the data scientist. It's their job to find those trends and patterns that are hidden in data. So like detectives, investigators, you really don't know what's going to happen. You don't know what you're going to find out. Okay, what you're going to discover. So yes, your intentions might be good, but then the outcome, based on all of the analysis that you do, might be it might cause inadvertent harm or even discrimination to groups of people. For example, in that case of Aling Lala, we actually started with the intention of just making sure that there's the right type of products for her customers, so that she will not run out of inventory for the items that her customer needs. But actually, one of the outcomes that came out there is that her most suke, kumbaga, the demographic of people that buy a lot from her are actually moms, okay, household, I mean moms who are not working, okay. We could have actually done and say, okay, let's just focus on the moms who are not working, and just make sure that we cater to their needs, okay. That would already discriminate all of her other customers. So that might cause inadvertent harm to, the other segments of the other customer segments of Aling Lala. So you need to be just cautious that it might happen. You need to just acknowledge the possibility that, certain harm um, can be a result of all of the analytics that you're going to do. And you just need to just make sure that you don't go that route. You need to still use the outcome where it's going to be beneficial again for everyone. Okay, so this is core in data ethics. This is core in using data for social good. First, you need to be very clear about your intention, and then second, you need to acknowledge that there might not be good outcomes, but you need to make a decision on how to use those outcomes as they come out of your analytics project. Lastly, and this is really just an invitation for everyone to help the Analytics Association of the Philippines build a data-driven Philippines. We invite you to become a member of the AAP, whether you're an academic or a learning provider institution, whether you're an organization, a non-government organization, a private company, whether you're an individual practitioner, we welcome you to become a member of the AAP. These are our website, social media pages. Today, actually, you might have missed it. We had our April meetup about artificial intelligence. So you can just head over to our Facebook page and review the recording of AI in the Philippines from our meetup yesterday. And then we actually also have monthly meetups. The May meetup is about digital responsibility. So a lot of discussion about data for social good. You can also view all of the recordings of our previous meetups and webinars also in our Facebook page. But then again, this invite goes to everyone. With the intent of helping the country be more data driven, we invite you to join the AAP. With that, I end my presentation. I know there's a lot of information to digest. I don't think this is going to be the last time that you're going to hear from the AAP, especially with an invite also from the Cebu ITBPM organization to work more closely together in the future to bring analytics and AI, especially in the Visayas region. Thank you very much. Magandang hapon sa ating lahat.
Thank you, Sherwin. So that's demystifying data science, no? Before we proceed to our next speaker, I'd like to call on the president of the Cebu ITBPM organization, Mr. Pert Cabatanya, to share with us briefly his enthusiasm about data science. President Pert?
Can you hear me?
Yes, we can
Okay.
hear you.
Well, thank you, Edie Buddy, and thank you very much, Sherwin, for acceding to the invitation extended to you on the behalf of CIB.O by Go Philippines now. And as Edie Buddy has hinted, I am indeed one of those who are strongly pushing for developing more skilled people in various technological sphere, especially in the area of data science. So thank you very much for accepting our invitation. But before we go, I'd like to raise a couple of questions, Sherwin. You have described some degree programs and whatnot. But in the meantime, while the degree programs are not yet producing the people, there are stopgap programs, if I may call them, no? Short-term programs. For example, the Sparta of DOST is one of those. And then we also have a number of free online courses, actually, on like, for example, from Microsoft, from IBM. And then mentioned in the flyer, bonus access to free online courses relevant to data science. Buddy, where is that coming from? From the GoField platform? Is it
Yes,
coming from the
from
GoField platform?
yes.
Okay.
We will have, I think, much of the discussion up when we have after our next speaker, our second speaker.
I see.
So
Okay. Oh,
we
there will be a
can,
Q&A later?
yes, later. There will
And
be a
will the
Q&A.
will the Q&A still have Sherwin there or no more?
Sherwin and our second speaker will be there.
Very good.
Right
Okay,
after.
so I'll reserve my other questions at that after that then. Okay, thank you very much, Sherwin. See you later.
Thank you, President Pert. And we now proceed to to our second speaker, who will share with us his experience on data science. Um, this guy has over 20 years of experience in the IT industry, 15 years of hand-on experience in business analytics, data science, machine learning, and artificial intelligence. He currently heads the business intelligence unit of Go Philippines and previously held the position of CEO at Veracity AI, a startup incorporated in 2018, primarily focused on data science and AI-based services and product development. As consultant, he has successfully delivered multiple projects related to digital transformation and data-driven generation. His experience spans across multiple industry verticals in mature and developing markets. He holds a master's degree in management science and quantitative techniques and a bachelor's degree in information systems from the University College of Dublin in Ireland. He enjoys working and developing talent in data-related technologies and is actively involved in the technology industry and communities in Sri Lanka. Ladies and gentlemen, let's put our hands together for Mr. Jerome Pereira.
Hi, thank you everyone. Greetings from Colombo, Sri Lanka. I'm very excited to join this event and share some of my experiences with you. And thank you, Sherwin, for basically setting the ground and educating us on the processes of data science and demystifying data science for us. I think that makes my job a lot easier. I was initially a little scared that what I have to say probably would contradict what Sherwin said, but I was quite relieved to see that, I mean, we were mostly almost 100% aligned in our thinking around data science and the industry around it. So without further ado, may I share my screen? Okay. Oh, okay. Can everyone see my screen? Sorry,
Yes.
that wasn't okay. Good. All right. So basically, what I want to do is kind of introduce you to my journey and my transition into data science, I started off as a Java developer and transitioned into data science. I want to talk a little bit in abstract about the career paths and options in data science as I see it, and kind of give you some of my final notes and thoughts on the subject. And as previously mentioned, Q&A will take at a later point on later session. So diving straight into it, I started off as a software engineer, software developer back in '99. After my second year in college, doing my degree, I switched to part-time and started working as a software engineer, software developer. And even after my master's, I kind of was involved in the software industry for a while, mainly as a systems engineer. But then I transitioned into a consulting career, and where I used to be a senior analyst, and I was working there for about 9 years and transitioned into the manager of the advanced analytics team. And post that, I've kind of continued that consulting career until about 2018, where I joined a startup by the name of Veracity AI. And basically, I've been in the startup industry and playing a prominent role in the industry here, as well as kind of looking at a global outreach through the organization. I've also been working as an independent consultant, and I, as of recent, have started a new journey with Go Philippines, and partly introducing the social enterprise to Sri Lanka as well, but also supporting the BIU as the head of the BIU. In terms of how I got there, I did my bachelor's in information systems, management of information systems, but I primarily worked in software development. But I was always interested in the subjects of decision sciences and quantitative techniques. So for my master's, I choose to go down that path instead of the software development path. However, I mean, as opportunities arise, after my master's, I took an opportunity in systems engineering, mainly with Oracle and Linux platforms. But that kind of paved the way for me to enter into a career in data science, or more specifically in business analytics, where I was introduced to a consulting firm that required people who could basically go in and query and analyze large volumes of data. So my previous experience with Oracle and databases kind of fit in very well. And I was able to kind of transition very smoothly into the consulting space and the analytics space. Now, that is where we started in terms of the analytics team where back then. But we slowly transitioned into more data science based platforms. So the main one we were using at that point was something called SAS. And then at a later point, we were using some SPSS as well, but we transitioned SAS into R programming. When you look at the third section of the career, I mean, it was a lot of Python.
Excuse me, Mr. Jerem. We
Yeah.
cannot see your screen.
Oh, is that any better? No?
No, we cannot
Okay.
see the slides yet.
Oh, I'm sorry. Bear with me. I am sharing.
Maybe if you could reshare
Yeah.
it, if possible.
Let me try. Yes, please. Bear with me. Can you see them now?
Yes, can see.
Okay. Okay, I don't think we missed much in that sense. So as I was saying, I mean, there was a lot of focus on the database side, but basically moving into more data science specific platforms. Right now involved in a lot more things to do with the cloud, deep learning, IoT, and digital strategy. Funnily enough, the tools that I have tended to use over the years has, well, over the stages of time, it has changed. But unfortunately or fortunately, now I find myself using a lot of these three at the end in my day-to-day work. So that's kind of a brief introduction to my career and how I got there. So basically, I want to kind of reiterate something Mr. Sherwin shared about data science and the importance of data engineering. So I didn't plan this previously, but it kind of fits nicely into what Mr. Sherwin was saying. So let me just share this. I hope you can see it. Please let me know if you can't. So as you can see, data engineering doing all the work, taking the data, looking for the opportunity, and passing the ball very accurately, and data science comes, makes a slam dunk, and takes all the credit. So, I mean, it doesn't always happen this way. I mean, we data scientists, I probably wouldn't call myself a data scientist, but data scientists are very happy to share the well, the credit of all the work. But as Mr. Sherwin correctly pointed out, it is a team effort, and there are a lot of people involved in the process of creating value from data. Yeah, so let me expand on that. We mentioned something called the data value chain. If I were to simplify it, and Mr. Sherwin explained the processes that go into data, converting data into value, so I'm not going to go into that. What I'll focus is the types of people who enable this. So these are, again, job roles from the perspective of job roles, and please keep in mind there will be a lot of overlap in these job processes and job roles. So, I mean, at a basic level, you have data management, which includes terms like data governance and so on, database administration that was mentioned. And usually there would be some sort of data analyst or a business analyst to create that value. But there are, again, I mean, as time passed and over the course of time, there are other roles that have been added into it. A data engineer, for example, a specific role for a statistician has become prominent, and there's currently a lot of focus on BI. Now, another thing to remember is you need someone as an interpreter. So there's a lot of information, intelligence that's generated, but you need an interpreter, usually in the form of some sort of industry expert or domain expert, to make sense of it all and convert them into actionable strategies. So that's an important role as well. And then, I mean, more recently, I suppose, with the prominence of things like machine learning, there's also a focus on a role for a DevOps engineer who can automate a lot of the tasks that go into training and retraining models and fit them into a production platform. Now, this is from a perspective more of a production level platform that will enable us to kind of provide services on a live basis to the client. So that's the perspective I'm looking at it from, a little high level and abstract, but kind of the same message iterated by Mr. Sherwin as well. Also, so what's a data scientist and where does a data scientist fit in now? So there are two schools of thoughts on this. I mean, I have two ideas on this. One is mainly that the data scientist plays a role in the the right-hand side of this diagram, where they are more exposed to or more expected to derive things like insights and intelligence from the data. But if you look at different industries or different domain verticals, the role of a data scientist usually kind of spans over the entire process. Now, you saw evidence to that in what Mr. Sherwin showed earlier in one of his slides, where the data scientist is kind of expected to, well, be an expert in most of those areas that he had highlighted, right? So there were, I mean, it was almost all 3 stars and 2 stars, the level of maturity that you expect in those technical domains of a data scientist. So that's kind of the role, but that does not mean that you need to know everything, which is the point I would try to iterate in the next slides. I looked at a few common available, I Googled it basically to see what are the recommendations in the roadmap to a career in data science. Now, there were 2 approaches. One approach kind of took a very sequential process where it is more about educating and learning and getting familiarized with all the skill sets that's required for a data scientist. I'm not a huge fan of this approach, although I know a lot of people would prefer a standardized approach to data science. But it also depends on where you are in your career. And if you are a student or if you're starting out, by all means, this might be a very good approach for you if you are looking to learn data science. The next approach is kind of looking at what you want to do in terms of providing value. Now, there are 2, this kind of divides it into 2 distinct career paths. One is more on the analytics side, which is more of a functional and less technical approach. And the other one is more of a technical approach where you can go from a data analyst to maybe a data scientist or to a systems developer. But it also identifies that if you are knowledgeable or if you are experienced in a certain domain or a certain function or a certain technology, there might be a different stepping stone or a different path to data sciences as you see it. So my main message here is, I mean, there are different approaches. There are enough and more resources out there. There are different approaches. So maybe a cookie cutter approach doesn't fit everybody. It's kind of up to you to identify, okay, where do you want to go in terms of your career, and why we've now identified, within data science or within data sciences or analytics or this entire data value domain, there are so many other roles that you might be able to better fit into. Now, as Mr. Sherwin kind of mentioned previously, right now there is a huge demand for data engineers, DevOps engineers, people who can basically, take that data to the basket or take it to a place where a data scientist can easily make use of it to derive intelligence, to do some analytics, derive intelligence and insights from that data, right? So currently that's a focus, and there are multiple approaches and ways that you can get there, and I encourage you to kind of figure out where you want to go and how you can get there through your own experience and where you are at the moment in your career. Looking quickly at who is hiring, because Mr. Sherwin kind of covered this, I broke it down a little differently. So I broke it down mainly separating traditional organizations. Now, these was covered in detail by Mr. Sherwin, so I'm not going to go into that much. But there might be other areas that would create opportunities. So when you're looking for a career in data science or a job in data science, you'll be looking at, okay, where are the opportunities, who is hiring? Now, I would like to focus on the 3 on the right-hand side, starting with new data. So what I define as new data here is basically not the traditional transactional data that you deal with as a primary source of data, but the other sources of data, for example, e-commerce data, IoT data, and social media data. Now, the explosion of data has kind of created a lot of opportunities, and there are for people who are looking for careers in data science, there will be a lot of opportunities with organizations that either collects or either deals with these new types of data. And of course, the other option is basically in technology services. Now, just like in Philippines, Sri Lanka also has a technology services focus, or we have a technology services industry. Definitely not as large as yours, but we have a, let's say, a little more focused in certain areas in the technology services. But I mean, technology services provides a lot of opportunities, and there is a lot of vacancies and demand, I would say, globally for jobs within this realm. And that's something that you can explore. And one option that kind of spans both technology services and startups is basically your ability to freelance. And I'll address this again at a different slide as well. I'll reiterate the point. There's a lot of movement towards freelancing. I'm not sure whether it was driven it was expedited or it was exemplified through the pandemic and the situation caused by that. But as of now, I think there are a lot of people who are providing freelance services, and that's a very attractive market, especially to people in technology services or startups. And also, this is something I kind of tried to iterate over here in Sri Lanka as well. There will be startups who are looking to capitalize on the new data and the technologies around data that are prominent right now in the market. So that's something that is definitely attractive for people if you're looking for something like that. And I would encourage you to explore opportunities in startups as well when you are looking for career opportunities in data sciences. Moving quickly on, I don't want to go too deep into this, but basically looking at the different types of skills. Of course, in traditional organizations, you would be somewhat looking at more stable commercialized platforms, whereas people who deal with new data, depending on the type of organization, whether it's a startup or a technology service, will be using different types of stacks and different types of technologies. Now, the key thing to understand here is the cloud platforms will anyway play a prominent role across the board, but the importance and the usage of things like open source applications and open source technologies will be more prevalent towards the right-hand side of the chart. So if you have skills in certain technologies, for example, in, let's say, Oracle or SQL Server, that might transition very well through, let's say, SQL Server into Azure and becoming or learning more technologies and providing more skills and involvement using different services from commercial platforms. On the flip side, if you are more of a geek, more of a techie, or more of someone who is interested in open source technologies, then you'll probably find a lot more opportunities in things like startups and technology services. So there's a spectrum of it, but you'll have to kind of decide what to learn or what to excel at and what to train in. One thing I want to highlight here is the missing link. So lots of people focus a lot on the technologies when they are looking to get in to a career in data sciences. There is less focus on these three things which I wanted to highlight. And one of those things Mr. Sherwin kind of expanded on very nicely, which was the ethics side of things. I also feel there are three main elements of this. So as a data scientist, you need to have some domain knowledge. So you can't separate the technology side of it effectively from the business side of it. You need to be able to understand the business problem and be effective in using the data to formulate strategies around that business problem. So the domain knowledge is essential for a data scientist. You also need to know about what to do with the data, what you can do with the data, and what you can't do with the data. So things like governance, privacy, security, and ethics kind of becomes prevalent. And the third most important thing that people usually don't focus on is the communication aspect. You need to be able to get a point across. You need to be able to analyze well, the data, the reports, or let's say the dashboards, whatever, but you need to be able to get the essence of it and communicate it effectively to the decision makers of the organization. That is the main, let's say, responsibility or the main tasks that is kind of expected from the data scientist in that design. So it can be, I mean, the receiver of the information can be, let's say, an industry expert. It can be the management, the leadership. It doesn't matter, but it's the data scientist's part of the data scientist's job to make sure the information or the intelligence is communicated in an effective and efficient way. So rather quickly, let's go into kind of where the or my thoughts on where the global market is headed. So as I mentioned earlier, there's a vast increase in freelancers in the space. Things like new technologies like IoT and Industry 4.0 creating more opportunities in the data science space, specifically because they are creating more data for us to play around with, for us to kind of do cool and interesting things with. But there has to be more data for us to kind of play around with it. So very excited about those two things. Big data, this is not a new thing, but it is still something that lots of organizations are struggling with using effectively. And one of the main reasons is the cost to value ratio. Now, there are certain use cases where it makes absolutely perfect sense. Quick one would be something like the telecommunications industry, where you use big data, Hadoop and Spark-based technologies to analyze things like network traffic and call data records, user data records. So that's something that the global market is still, I think, maturing in. And the other point there is the focus is still a lot on the data layer. And this is predominantly true more in emerging markets. For example, Sri Lanka is a good example for this because even the largest organizations sometimes are still kind of finding their way in having the underlying necessary data structure and the necessary data infrastructure to make use of their data optimally. And it's true in many other markets as well. Data aggregators, there are a lot of people who are looking to collect data. And I mean, for example, this this was Google's data model as well, and lots of other large enterprises use this data model. But you will also find lots of very specific aggregators by market who are focused on different use cases or different market opportunities. And definitely open source is in the future also going to play a pivotal role in the data sciences in extending the the reach and the application, as well as making it free to use for everybody. So I'm a big fan of open source technologies. And of course the cloud, which is the in my opinion one of the sole factors that helped us kind of come exponentially grow in our usage of data and these technologies around data, and made it kind of a lot more easier to use and accessible to everyone around us. So yep. I think I'm in my couple of last slides. So basically, just to summarize, in terms of shifting into a data science career, now I wanted to highlight this. This is basically what you call the four realms of knowledge. So in knowledge, there's this theory which says there are four aspects of it. There is what you know that you know. So there are things that you are very certain. You know the sun is going to rise tomorrow, but translate that into a more technical aspect. And then there are things that you know that you don't know. So for example, you might say, yeah, I don't know Python, right? On the bottom rows, there is what you don't know that you know. So you might not know Python, but you might be able to grasp the concept of Python because you know a different programming language, right? And the same concepts are used in Python. Then on the other side, which makes up most of our knowledge, and again, you can translate this into the technical terms or the technical framework, but this is basically as big as the universe. What we don't know that we don't know, we haven't even heard of it. There are so many things out there. Now, the point I wanted to make here was there are opportunities or industries, industry verticals, or even things that you are good at that can flip this chart upside down. So there will be domains for you that you know very well. Now, if you are someone who is already having a career or who is a little way along in their career and your domain is different, or you have some domain expertise or knowledge, my advice is start there. Figure out where you can extend that into and what you can learn from what you already know, and always keep the the direction in line with what you need to learn to become a data scientist, and very soon you'll get there. So that's it from my side. Just finally, to wrap up, I just wanted to kind of give you an indication of the state of the art right now. So I'll use a quick example that I came across recently. I went to a seminar on what was called artistic machines. So the speaker there was introducing how we are using AI to generate art. Now, one of the problems that this guy is from Google DeepMind. Is from DeepMind. He's a scientist at DeepMind, and his research is around how you can use AI to generate art. Now, when they tried to do that, one of the things they had to do was they had to define what was art. So they concluded art was something that creates curiosity, or helps, create someone to stop and think about it. So basically curiosity. So then when they wanted to make a computer create art, they thought, okay, what is the best position if I had to put one pixel on a canvas? What is the best position to put that pixel? Now the obvious answer is in the center, but apparently that's not art. It wasn't deemed by me. It was deemed by the expert artists and the panel that was there. Putting a pixel in the center isn't really art. The obvious choices are out. The four corners are out as well. So what they finally concluded was it is a place that is, well, not in any of the verticals or horizontal lines, or not in the diagonals, or not in the corners. It is something totally random. So with that, I would like to kind of open it up to questions. And thank you very much for listening to me. And good luck, everybody. Thank you. Bye.
Thank you, Jerome. That was a lengthy share of experience on data science. At this point, let me invite once again Sherwin to join us in the Q&A. Okay. We have the guests in the in the room, and I think we once again let me acknowledge the presence of our guests. No, we have over 300 guests this afternoon, and of course you can shoot questions by raising your hand, raising the hand signal in the platform so that we could recognize you. Um, at this point, I'd like to give the opportunity, the pleasure to CIBO President Pert to ask the first question that he would like to raise with Sherwin earlier. President Pert?
You hear me now?
Yes, we can hear you.
Thank you, everybody, and thank you, Jerome, for that sharing of your real professional experience in the field of data science and analytics. A lot of the people in the audience are students, but at the same time, they're also academicians in there and professionals already who may want to reskill and upskill. And so they're dropping by to listen to what you are sharing. So I wanted to go back to the question that I wanted to ask Sherwin earlier. It has something to do with the urgency of producing people with the right skills. No? And it is very good that AAP and Sherwin are working together to develop the formal degree programs through the schools to produce those kinds of skilled people. But like I said, while we're waiting for those programs to be fully operational and producing regularly the people, we have to have urgent stopgap programs to also produce people because there are, like I mentioned, upskillers and reskillers who may want to pick up new knowledge and skills in the area of data science and analytics. So the question I'd like to raise and address to Sherwin, being in AAP and in the Philippines, is in your assessment, how effective is the likes of the online programs, basically the likes of Sparta, for example? How effective is it in producing certified individuals? How many? Maybe one way of answering it: how many have graduated from Sparta over the past 3 years?
Okay, that's a very good question, Sir Pert, no? Well, first of all, the project Sparta was designed based on the professional maturity model, the competency framework that we showed you, and in essence, what Jerome also highlighted, the roles and the skills. There is also some basis in there. The skills that Jerome, for example, mentioned, you'll find that in Sparta. So it was really designed to address the skills that were identified in that APEC project there. So what we're saying is that if you learn that, then and you graduate that, you'll have the competencies that will be at par with the others in the APEC region. That was the intent of the development of that framework. So it was designed to be modular, but at the same time, it was designed for those pathways. You can be a data steward, data engineer, data scientist, etc. It's a fair question then, sir, to ask how many have graduated. At this point, with the goal of 30,000, unfortunately, we're actually less than 1,000. Okay, because of the so many challenges, and there's a lot of discussion with the OST about that. Well, my reasoning there is we've offered it for free. We didn't put any. Unfortunately, we should have put some penalty clauses there. If you can't complete it on time. So it was completely for free. So people took for granted how important it was. But in any case, there are initiatives right now, because for the example of the experience of Jerome, and as Jerome also nicely put it, in that the path. And I like the Jerome. Can I borrow that? You know, when you start with the probability math statistics, that's the normal path if you want to educate yourself. But with the experience of Jerome, Jerome actually had to, because he has already some skills, he had to start somewhere already. He doesn't need to take all of the other competencies or the other subjects in there. In Project Sparta, there's now a move for so that skilled people who would have already experience, say, in visualization, communication, in stat, you don't need to take that anymore. You need to just look at the subjects or courses where you need to build more of your skills. You might feel that you might be missing some of the programming skills, okay, and you want to know how to program in Python, then just take the Python course. You need to know to be able to tell more compelling stories with your data, then take the data visualization storytelling courses. So Sparta is now going to evolve into something that would cater to those who have already some skills in some areas in analytics, but they just need to develop additional skills to complete their role in, say, being a data engineer, a data scientist, or a data analyst.
Yeah, thank you very much for that, Sherwin. The reason why I raised that question because I actually have a feeling that you would answer that way because I heard from somebody else. I just forgot who it was. I think it was the OST itself who told us that the availment, the success rate of getting people to finish Sparta courses has been rather low, and they were inviting us to also help. And I checked with Microsoft, I checked with IBM. They also have similar free courses online. And similarly, the completion rate is also low. So I have a hypothesis. The hypothesis is, despite the fact that these courses are free, there's a lot of interest. A lot of people get in and start, but they don't finish. So my hypothesis is that they don't finish, although they are interested. It's because number one, nobody's pushing, nobody's managing, nobody's managing them. Excuse me. Number two, there may be a need for an extra kick, extra incentive. Okay. So therefore, when we cook up this CIBO Connect platform, which we are operating with GoFeel, the idea is to provide those two that are missing. Number one, provide a management of the participants so that somebody will be there to keep track and push and remind, etc. Secondly, there's got to be some kind of incentivization, reward for finishing something. If you look at a school setting, for example, if you offer these courses in the school, those two exist. No? The management is provided by the teacher, provided by the school administrator. The incentive also exists in the form of if you pass, then you get the grade, you go get near your graduation. That's the incentive. If you fail, then you will be delayed or you won't finish at all. So it exists there. Similarly, outside of that school system, we should have something that will manage and incentivize. So that's what we are seeking to provide through our SIB.O Connect platform. And yeah, I'm just sharing that with you, Sherwin, because you indicated that you wanted to continue working with us, and definitely we want to continue working with you too, with AAP, in order to achieve the goal of producing more people who finish the courses, get certified. That's our goal. Yeah. So I'm glad that we're here together today to share that common direction. Yeah. Buddy?
Thank you, President Pert. One question was read to me earlier. What is the status of data science today in the Philippines? So maybe Sherwin would be in a better position to answer this. Or there are two questions that were given to me actually. What's the status of data science in the Philippines today, and how many certified data scientists do we have in the country?
Okay, that's a very good question. We've I don't have the numbers in the labor market intelligence report, and I'll give you the link there. There is already kind of a survey that we did. If you look at data scientists, the way that we defined data scientists, we don't have really that many at this time. In fact, there's actually a shortage of supply. There's a lot of demand, but we basically need to produce more of those, data scientists and data engineers. That's why we're also pushing for, people to complete Project Sparta, more programs, education programs. But in as far as those that, the data scientists that we do have, skills wise, competency wise, they can actually compete with other data scientists in the world. We have globally competitive data scientists. I think one of the things that even for these data scientists, one of the things that might be missing still, and what Jerome highlighted, is deep domain knowledge. Okay, our data scientists are good in the programming part, but if you ask them, can you create something for the banking sector? It's they're still struggling, on combining the math stat, the programming with the understanding of the banking sector, for example. So I think that's and again what Jerome highlighted. That's very important. The domain, the industry skill. We're slowly getting there. I mean, data science is fairly young here in the Philippines, but the interest, like what President Bert said, the interest is very high. What we also want to do is also together with the DTI, we're identifying the Department of Trade and Industry. We're identifying, the key industries where we want to build more data science and analytics professional. Industries such as agriculture, manufacturing, IT, because those really are the key industries of the Philippines. We're still an agricultural country, right? And we need to be more data driven in that. We're not going to ask people to become farmers. Now that's different. It's now we're going to build data people who will help farmers, be more data driven. So I guess again, going back to what Jerome said, that's where probably going to be focusing on, building data people in this specific industries, specific domains that we are going to focus in the Philippines.
Thank you, Sherwin. Indeed, it's a challenging industry, and a lot of young students actually are looking at the possible career in data science. It's just a matter of understanding the whole thing and navigating as to where they should be heading. What about the industry in Sri Lanka, Jerome? How's the
Uh,
data science market in
okay.
Sri Lanka?
So I mean, it's not as mature as we would have liked it. So back in 2017, we had a huge program that involved universities and industry professionals and some experts from overseas to kind of drive the interest of students into data science. So as a result, I think last year and this year we will have quite a bit of output in terms of students who have learned a bunch of these technologies. So students who have taken specific degree programs focused on data sciences. Excuse me. On the flip side, we don't have as many as experienced data scientists as I imagine you would, as Sherwin mentioned, because to us even it is very it's a very new industry. It's a relatively new industry or a new technology space, and unfortunately, we are also experiencing somewhat of a brain drain in this area, to be honest. So that's another aspect that we are looking to control as well.
Okay. Yeah, indeed. I believe in the Philippines, it's a bit challenging also, no? Since we're almost culminating, given the time frame that was allocated to us, I believe we have to deal with this one last important question before we adjourn before we culminate the session. Somebody was asking, what are some of the downsides of data science? One quick answer, Sherwin.
There's always the danger that you might do something. I mean, in the discussion that have, you might fight something that you don't like. That usually happens in the when you discover something, and then you might be forced to um, do something else. There's that saying that you can actually torture data to the point that it can tell you whatever you want to say. There's that danger of over analyzing, so that your analysis will really suit whatever you want it to appear, the outcome that you would like. So that's really one of the dangers. And I think, okay, the
I think data
the
mining, Sherwin, no?
yeah,
Data mining, I believe, is
right,
one of the
yeah.
the
And then I
fears
think
now of a lot of people.
the other the well, this is the real danger for me, is that when we do analytics, when we aggregate all of these, when we come up with numbers, we usually end up with just saying that there's this statistic. Like, for example, how many, I forgot how many people in the Philippines died in COVID, X number of people. The danger always there is that we reduce a person to that number. When we reducing a person to a statistic, that we forgot that there's a person behind the number. When we aggregate all of these figure, we're saying, say, 80% of our population is don't are below, say, the middle age. You forgot that one that's actually part of that statistic. So we tend to generalize based on a number, and we don't cater anymore to the needs of the specific individual. I think that's the more pressing danger that we have. So we just don't need we really have to remember that for every number that we have, there's a person behind it, and we still need to take care of the needs of that specific person behind that number.
Okay. Um, Everything has a good side and some downside, I believe. Hopefully, um, we will not go deeper into the downsides, no. But there are dangers. If there are advantages, sometimes there would be disadvantages. Um, we have reached to the finish line of the time allocated for us in today's session. I believe it's about time to say goodbye to everybody. At this point, I'd like to remind everyone that today's event is a career building program of the Cebu ITBPM organization, dubbed the CIBO Connect, in partnership with Microsoft and Go Philippines. We have a platform that the audience could uh, explore https://cibo.gophilippines.org for all our participants to explore the training programs and the projects that are for free, offered for free there to be able to build your careers. Um, Thank you very much for being with us today, and we hope to see more of you in our next sessions. I'd like to uh, thank Sherwin and Jerome for sharing everything to us as to where we should be heading um, relative to data science. President Pert, thank you for your participation also, and to our lovely MC. Um, I'd like to give you the floor uh, to end the session today. Thank you.
Thank you so much, Sir Buddy. So once again, we would like to thank Mr. Pert Cabatanya for joining us this afternoon. And of course, we would like to thank our subject matter expert speakers today who joined us and who shared their insight and their expertise. We would like to thank Mr. Sherwin Pelayo, the Analytics Association of the Philippines Executive Director, and also Mr. Jerome Pereira, Go Philippines Head of Business Intelligence Unit. And of course, thank you so much, Mr. Buddy Villasis of CIBO Philippines, for hosting our program this afternoon. And most especially, would like to thank all our participants today. Special announcement before we close the session, we will be sending you a link through your email for the feedback form. Upon completion or successful completion of the feedback form, you will be receiving a certificate of participation that you can also download. And finally, stay tuned for more webinars of CIBO through their CIBO Connect platform. So once again, good afternoon, everyone. Have a pleasant weekend. Thank
Very
you.
good.
Thank you. Have a great
Thank you,
weekend,
everyone.
everyone.
Good
Thank
weekend.
you.